Okay, passage 5. I've zoomed out here a little bit so it's easier to see things on one page. So if you need to see something up close, you can zoom in on the video. Researchers conducted an experiment to determine the factors affecting heat flow. In each trial, one or more blocks of a particular material was or were placed between two walls at a constant temperature, at constant temperatures T1 and T2. So they were different, but they stayed constant in one of the configurations shown in figure 1. Heat was transferred through the blocks from the hotter wall to the cooler wall. Okay, this heat flow measured in joules per second is shown in table 1. All blocks used in the experiment were identical in size and shape. In each configuration, the contact area was the surface area of the end of the blocks against one wall. Okay, so we got a block of something here. We got 2 blocks stacked, then we got 2 blocks back to back, and then we've got 4 blocks back to back. Okay. And then down here it tells us what the blocks were made of in each configuration. And they did different trials. Okay. And so they did glass wool in all 4 configurations, and then they used glass wool in configuration, and they used a bunch of some different types of materials. Okay. According to the information provided, heat flowed from the wall at temperature 1 at temperature T2 to the wall at temperature T1 in which trial? Okay, so it went from from T2 to T1. So T2 has to be hotter. 4, no. 6, yes, that was hotter. 10, no. 12, no. The only one that T2 was hotter for was trial number 6. Okay. And that's just something I have to know, that heat's going to go from the hotter to the cooler area. Oh, no, actually it says from the hotter wall to the cooler wall. Oh, so they already gave me that information. 26. Insulators are materials that are poor heat conductors. According to trials 7 through 10, okay, so I'm looking at 7 through 10 down here. I'm going to just mark it. A wall of a given thickness built of which of the following materials would provide the best insulation between a room and the outdoors? So we want a material that has very little heat flow. We don't want the flow going away. We want it staying. Okay, so which of these has the lowest heat flow? Wood. Wood has the lowest heat flow. And this sort of makes sense. If you built a building out of aluminum, it's going to heat up really fast inside. But a house of wood doesn't heat up as fast. Okay, cool. So, wood. Number 27, the results of trials 1 and 5, so 1 and 5, are consistent with the hypothesis that heat flow from a hotter wall to a cooler wall is dependent on the, let's see, what is this measuring? So these are both configuration A, and the heat flow is the same, and the material is the same. The temperature difference was 30 degrees, and this was 30 degrees. So, what was different? That heat flow from a hotter wall to a cooler wall is dependent on the temperature of the hotter, no. Temperature of the cooler, no. Sum of the wall temperatures, 20, 30, 40, 50, 70, 80, 90, 100. Difference between the wall temperatures. Okay, so they both had the same heat flow, but they had different temperatures, but the difference of the temperatures was the same. The temperature of the hotter wall didn't make a difference. The temperature of the cooler wall didn't make a difference. The sum of the temperatures, this would be 170 and this would be just 70, and it was still the same. The difference is what made the difference. Huh, that's cute. Okay, number 28. Materials differ in their thermal conductivities. The higher the thermal conductivity, the greater the heat flow through the material. Okay, so as this went up, thermal conductivity also went up. According to trials 6 through 11, let's do 6 through 11 over here. Okay, so those are all different kinds. The greater, which of the following statements about relative thermal conductivities is not true? So I've got to find which one is not true. So I'm going to have to look at every one of these. Brick has a higher thermal conductivity than glass wool. That is correct, because these go up in order. So that's true. Brick has a higher thermal conductivity than wood. So brick, it's going up this direction. So yes, brick is higher than wood. Steel has a higher conductivity than aluminum. But no, on here, steel is 31 and aluminum is 140. And so this is not true, but let's make sure. Steel has a higher conductivity than concrete. Yes, that's right. Concrete is below steel. So H is correct. And number 29. Trials 1 and 3 provide evidence that heat flow depends on which of the following factors. Trials 1 and 3. So glass wool, everything's the same except the configuration and the heat flow. So the configuration is what changes. And it's the same material. So A looks like this, and C looks like this. And so the distance between the walls is greater. And the heat flow is lower. So distance between the walls did affect the heat flow. Contact area, the contact area was the same because that's these where it touches these. So these were the exact same. Temperature of the hotter wall, no, and these were the same. So the only thing that changed was A, the distance between the walls. All right, done with passage 5.